Hello and welcome back to our continuing discussion on building applications in Alpha Anywhere. I'm Dave McCormick, VP of Product Management here at Alpha Software. Today we're going to be talking about, first of all, about building applications, of course, and about the things that are required when you launch an application. In the past, we've covered things such as building a two-factor authentication capable login system, how to work with databases, how to build out user management screens, how to make your application mobile friendly, and also how to give it some visual appeal. And we've covered some options when it came to deployment, but today we're going to take a look at deployment in greater detail. So, of course, the easiest way to get your application up onto the web is by using Alpha Cloud. Alpha Cloud is actually built right into the Alpha Anywhere developer. You can get there by clicking the Alpha Cloud button. You can purchase a subscription, and you can just, with a couple of clicks, basically get your application up and running securely in the cloud. It costs $99 a month, and a lot of people go with this option. But there are some cases in which you might say to yourself, I would prefer not to go with Alpha Cloud, maybe for one or two reasons. One is, $99 a month isn't a lot of money, but maybe this is some sort of small project that you're doing on the side that you're developing, and it's sort of outside of your budget for now, and you'd like to find some cheaper way of implementing Alpha Anywhere. Not quite as good as the cloud. We'll go over the differences later. The other thing is that you may also want to build out something very custom and specific, or maybe you have some data governance regulations in which you really need to do an on-premise hosting of everything, your application, your database, whatever. So for that reason, you might decide that you would like to self-host over going with the cloud as well. So there are at least a couple of good reasons for doing that. And today, whatever your reason, we're going to be talking about on-premise hosting. So this is a really simple diagram. Basically, you have some people who are connecting to your Alpha Anywhere application. Maybe it's on a phone or laptop or desktop computer using a variety of browsers. And when they connect they basically go right onto your home or office network and access the Alpha Anywhere software. Now, there are a couple of problems with doing this. This is a way which some people do host, especially for doing this in a network operations center. This is a pretty common scenario. But if you've got a home or office network, chances are a couple of things. First of all, you don't have what's called a static IP address. In other words, the IP address that you connect with may change from time to time, and that's no good because when it changes, your clients won't be able to find you unless you update some DNS records. The second thing is that for most home office or even small office network setups, your ISP blocks the port 443 and port 80, which are required for your clients to connect in using the standard ports to get to your network. And they're blocked for a variety of reasons. Some of them are actually quite good ones that have to do with security. Because, the question is, do you actually want outsiders coming into your own home network? Instead, they'll know what your IP address is. And if you have everything locked down properly, that's fine. But a much popular or easier way of doing it is by instead using something that we call a reverse proxy. So let me show you what that would look like. With a reverse proxy, the clients don't actually connect directly to your computer. They connect instead to the reverse proxy computer. The reverse proxy takes the requests, which come from the various clients, processes them, and then sends them back to the development machine on this side. The home office or network machine will then pass that information back into the clients. And this is also a very secure way of doing it. We use standard HTTPS or the SSL and TLS to connect the clients to the reverse proxy. And you do that with a security certificate. And then this also uses a security certificate to make what's called an SSH connection between the reverse proxy and your network, your home office network. So today we're actually going to talk about how you put something like this together. So what are actually the requirements if you wanted to build out a system like this? It's It's actually easier than you think, and today I'm actually going to show you exactly how you do it. So there are two pieces. There's, first of all, your machine. That's the one that you have Alpha Anywhere running on. The only thing it actually requires is for you to be running Alpha Anywhere on it, as well as be running Windows 10 or above, which is already, I believe, our system requirements for Alpha Anywhere. So chances are you already have this piece already taken care of. Over here on the reverse proxy side, what we're going to be doing is we're going to be running a piece of software, a reverse proxy called Nginx. Nginx is also a web server and a couple other things. We're going to talk about it in a little bit more detail coming up. Nginx runs on almost any operating system, so it almost doesn't matter what operating system you choose for your reverse proxy. But your reverse proxy is going to need to have a static IP address, and those ports 443 and 80 cannot be blocked. You need to have those opened up. So those are all requirements. The other thing you're going to need is you're going to need a domain name. And the reason you'll need a domain name is you'll need it to get an SSL certificate. The SSL certificate makes sure that your data is encrypted between the client and the proxy server. And I would not recommend running it any other way. Nowadays, everything really should be encrypted. I'm going to show you how you get that set up as well. So let's start with the kind of machine that we're going to use for our reverse proxy. I actually went and got a machine over here, a virtual machine over at AWS, over at Amazon. So when I signed up for my AWS account, I went into the section called EC2. That's where you actually get the virtual servers. That's what they call it, EC2. And right up here, you'll see a big orange button called Launch Instance. When you click that Launch Instance button, it'll take you to a screen which lets you build out a virtual server. So now you have a lot of options to go with. And the option that I selected for today is Ubuntu. And the reason I'm going with Ubuntu is because it is a really well-documented version of Linux that works really well with Nginx. So if you really have any questions about configuration and stuff, it's very well supported under Ubuntu. So when I chose Ubuntu as the operating system, then I was given another choice, and that was what kind of hardware do I want to run with the Ubuntu. And so those are called instance types. These are sort of predefined ones here. And I think it defaults this one to the T2 Micro, but I actually chose one even smaller called the T2 Nano. Now, the pricing on this is terrific. It is about half a cent per hour to run this server, about $5 a month if you want to do the math. And that's really all we're going to need for our proxy servers. We can run something as small as this. So that was actually the one that I selected. Now, after you choose the instance type, the next thing you're going to want to do is hook up what's called a key pair. And so this key pair is basically it's a key certificate that's built, and it allows you to connect to your server using SSH. When you build that key pair, when you create that key pair, you just do that by clicking the Create New Key Pair button. A dialog box appears. And basically, you just give that key pair a name. You might call it My Certificate or something related to whatever project you're working on. And then for the key pair type, you're going to want to choose RSA, and the file format is a .pem. So these are really just the two choices here. You can get a different type of certificate, but it's not going to work for our purposes. Once you do that, you just click the Create Pair button, and instantly that downloads basically a little file, PEM file, to your computer. You're going to need this later on the machine that you are going to run your Alpha Anywhere server. So you want to keep track of this PEM file. All right, then the last thing we're doing when we're setting up our network when we're setting up our virtual machine is setting up the network settings. So the network settings, you basically leave everything alone except for these last two where it says allow HTTPS and allow HTTP traffic. You want to basically open up ports 443 and 80, which you do simply by checking these boxes. Now, if you forget to do this, I'm going to show you another way that you can open up those ports later on. But do check those. It'll save you some time and hassle. Once you do that and you press the Create Instance button, it actually goes and configures and builds out your machine. My experience is that this often took less than 60 seconds. I was absolutely amazed by that. And when you're done, it's going to take you to a screen which tells you information about the server that you just set up. There are two things on the screen that you want to take note of. The first one, the big one, is the public IP address. This is now the IP that you can go and connect to your server using. There's also something up here. There's a connect button, which will actually open up an SSH connection for you right here in the browser. I found that really handy. So when you click on that connect button, it opens up your server. Now you can see the server, it's all text. We're only going to be working here in what's called a command line interface today. We're not going to be using a graphical user interface, so it won't be a lot of pointing and clicking. But don't worry, there's actually very little that we have to set up on this server, and I'm going to show you exactly how we do it. So let's just have a quick review and see how far we've gotten. In these few minutes, we've actually gotten halfway through the process of setting up a reverse proxy server. We've selected an operating system, and we chose something which has a static IP address, which ours does, and we just saw what that was in a moment ago. And we've opened up the incoming ports for HTTP and HTTPS. So that leaves us with two more things that we need to do. We need to set up Nginx, a domain name, and an SSL certificate. Let's talk quickly about Nginx. Nginx is actually the world's most popular web server. It has the largest market share, or at least it did as of June 2022. It can be used as a web server, but it can also be used as a reverse proxy, and it can be used as a load balancer. Today, we're going to be using it as a reverse proxy. So I'm going to go ahead and we're going to see how we do that. What we want to do is we want to go back over to the Amazon console. In other words, log back into our computer, and we're going to install Nginx. And we're going to do it simply by typing in a couple of commands. The first one brings our operating environment up to date, and we type in sudo, S-U-D-O, apt update. And after a moment, that runs and it updates your machine just to make sure you've got the latest and greatest of the stuff that you need. And then the next part, sudo apt install Nginx. That goes out, finds Nginx, and it installs it and has it operating on your computer. After you've typed in those commands, believe it or not, you've got a website up and running at that public IP address. So if you went to a web browser and you said http:// your IP address, you'd be able to see something that said, welcome to Nginx. That's the default page that you see when you get to your server. So wow, we've actually now got Nginx installed. So we're really cruising. We only have a couple more things we need to do. We need to get the domain name set up and the SSL certificate. Now, a lot of you have probably bought a domain name before. There's a bunch of different places you can get it. I happen to get one from, well, GoDaddy, but you can get them anywhere. It doesn't really make any difference. Whoever is the person who registers and manages your domain, you're going to want to log into your interface there, and you're going to want to go and manage that DNS record. So we're going to go into Manage DNS, and we're going to take that public IP address, which I just showed you a few screens back that we got from Amazon, and we're going to insert that into what's called the A record. We do that in GoDaddy by hitting this little pencil. Most interfaces are pretty similar to this. So you're going to add a record, you're going to point it directly here. And as soon as that's done, you might have to wait for as long as 10 minutes, 15 minutes. For me, it happened instantly. But what happens is you can now go to yourdomainname.com. So we're still HTTP, so it's not HTTPS yet. There's no secure certificate. But we're now at the point where your domain name is responding now to Nginx. So that's cool. So the last thing we need to do now is get an SSL certificate, which we can do because we got our domain name. And we're going to be using what's called a service called Let's Encrypt. It is a free service, and it is unbelievably easy to use in Ubuntu because there's actually an integration in Ubuntu which sets up everything for you. So even though we're looking at the Let's Encrypt website, there's actually no reason you actually have to go to the Let's Encrypt website to do anything I'm about to show you. So this is what we're going to do. We're going to head back into the Amazon Web Console, and we're going to go back into our system, into our Ubuntu system. And we're going to do some more commands here to add the certificate. So we've got 5 things we're going to type in. We actually only need to type in 3, but I'm going to go over them with you right now. The first thing I'm going to point out is sudo sudo. It basically means that you're permitted to run this on the server. If you leave this out, it will not work. So make sure you say sudo in front of each of these. So UFW, which is Uncomplicated Firewall, is a system that's built into Ubuntu. And by saying UFW allow 80, it just means open up port 80. Now, we did this earlier, so we don't really have to do this now. But if you had forgotten to do it, you can do that to open up port 80 and to open up port 443. The next thing we're going to do is we're going to install the Let's Encrypt package. And you do that just by typing in this line here. And when you hit enter, it goes in and installs it. And then we're going to install this other package. And this other package is really cool. We're going to install this package called Certbot. So it's Python 3 Certbot Nginx. Certbot handles all kinds of cool things for you. In fact, if you take this line, this one magic line here at the bottom, and run Certbot, and you basically give it these parameters and your domain name, what will happen is a box appears on the screen asking you for a few bits of information like your name and things like that. And it goes and creates a certificate for you. And this is actually what you'll get back. This is what you'll see on the screen. Successfully received the certificate. It's saved the certificate for me. It tells me when it's going to expire. It's actually set up a task. Oops, back to that page. Set up a task to automatically renew the certificate when it comes up for expiration. Not only that, it's also done the configuration in Nginx for us. How cool is that? We did all of that just by typing in these lines right here. In fact, this one line right here actually did all the work. So the upshot is, if we go over to our web server now and go to HTTPS, we will see that we now have got a secure connection to our web server. And now our job is complete. Well, mostly. Not entirely complete. What we've actually built is a secure web server, which is cool. Not quite what we want. What we want is a reverse proxy. And so we're most of the way there, and that's because we're using Nginx, and we just simply now at this point need to tell Nginx that no, we don't want to be a web server, we want to be a proxy. So when these come in, I don't want you to serve the requests, I don't want you to serve the files, I want you to pass them along to a different application. And I'll show you how we do that. We do that by editing the file. This is probably the most confusing section here, but it's not that hard. By going back into basically our console, we are going to, if you're not familiar with Linux, maybe you're familiar with DOS, it's pretty similar. When you get to your $ prompt and you type in CD and this, etc., Nginx, sites available, it basically moves the working directory so that you are in this sites available directory. This second command that we issued, sudo nano default, which again, sudo means I have permission to write and read this file. Nano is the text editor that you're seeing here, and default is the name of the file. In fact, you'll see the names up here. That's going to open up a configuration file for Nginx. And as you scroll through that, you're going to find that Certbot has been here before you. In fact, just a moment ago, it made some modifications to this file. When you get down to that Certbot section, you're going to want to paste in this section here. And we'll give you details later about how you can get this stuff so you don't have to just type what's on the screen. You'll be able to copy and paste. So, but let's take a look at this. This gives Nginx a bunch of information. One of the key things it tells it, though, is that the incoming traffic you want to send to port 3000, internal port 3000, so that it can be picked up by Alpha anywhere later on. There's some other things that might be useful to you, the connection timeout, send timeout, maybe buffer sizes. I'm really not sure. I'm not an Nginx expert. Fortunately, I worked with one to create this, and I think you'll find that these settings should work nicely for you as well. If not, there is Nginx being the most popular website. There is a lot of help and information out there on the web to do that. So the only thing we had to do after we had finished pasting in those updates to our default file is restart our web server. We do that using this command here, system control restart Nginx. And now when we go to our domain, we'll see that it says 502 bad gateway. But don't worry, this is actually a really good sign. What it means is that our server is no longer acting as a web server. It's now acting as a gateway, as a proxy. The problem is of course, that Alpha Anywhere isn't yet connected to it. So it's taking the requests and trying to send them somewhere, and it's not going anywhere. So that's why you get this error message. So what we need now to do, our last step, is we need to now hook up our Alpha Anywhere server to our reverse proxy. And we do that right on that machine. So what you would do is you would open up a command prompt on the DOS machine where you have, on the Windows machine where you have Alpha Anywhere running. And in that prompt, in that command window, which you could type CMD will also open up that window for you. You're going to move to CD to downloads, probably is where you will have saved your PEM file. But really what you want to do is you want to change directory to the directory that has that PEM file that we created earlier over at Amazon, right? Once you're there, you're going to issue this command, SSH -I. So the I tells it that I want to make an SSH connection. I don't want to enter in my password. Instead, I want to use this key to connect. Then I give it my username, which is Ubuntu. That's the name of the machine that's what my machine was named when I created it. And my default username is Ubuntu when you're building a machine. Then and then the public IP address. And then this gobbledygook here says, take that stuff that you had routed to port 3000 and route it to port 3000 on my machine. So basically all you do, you can just copy and paste this and run that. And when that happens, you'll see actually the window changes. See how it said command prompt? And now it says you're connected because it now knows that you're connected by SSH. So you're connected and you actually have a prompt. And you're here in Ubuntu much like we were in the Amazon Web Console. So this is just an alternate way of getting in and working on the server if you want to. But you can just leave this window open, and keep in mind we're working with port 3000. We're going to need to pop over to Alpha Anywhere. We're going to need to go into the web development server and enter in port 3000 there. Once that is done, if you go to the domain, for example, you will see that it loads up the application. And this is the sample app that we had worked on, I don't know, about a month ago. And this is up and running right now. It might be up and running for you right now. Go ahead and type in the URL if you want to give it a go. It's goofcanoe, GOOFCANOE.com. You're saying, how did I come up with that name? I just thought of two words and stuck them together. There's no real meaning to it. So anyway, so that's it right there. And now everything is running. Now, there are some limitations. We're going to talk about those limitations. A lot of them apply to the Community Edition, but there's some other limitations as well. When you get Alpha Anywhere, the Alpha Anywhere Community Edition, it does have a development server of a sort built into it. But it's got a limitation in that you cannot actually publish even to your local host. The only thing you can do is take a look at your pages in live preview mode. So as a result, when you publish, your people could still access your application, but you're going to need to insert this underbar live test / in order for them to be able to see the pages. This isn't ideal, but that's a limitation of the Community Edition. The other limit of the Community Edition is that you have a limited number of people who are allowed to simultaneously connect to your server, another number of sessions that are allowed to be open. A session has to do with how long a session is being stored on the server. You can change that. If someone logs out, that session is considered closed. And if you want to have more information about it, just click this Understanding the Session Limit here in the Developer Settings box. Now, if this were not the Community Edition, which it is, but if it were not, I would have the ability to add a license into my Developer Edition, and which I've done in my actual Developer Edition. If you can see, let me go back a few things. Here it is. Don't steal my license. It's already assigned to me. But this is it. And so I don't actually have a limit to the number of connections that are allowed to be made to my machine because I have the full edition of Alpha Anywhere Developer. Also, if you do get a license, you can purchase the Alpha Anywhere Standalone Application Server, which means that you don't have to have your Alpha Anywhere developer running. You can basically have a small separate program in the background running as your server. We also make a version that runs with IIS, which gives you bigger throughputs. So those are a bunch of options that you have there. But this, if you can live with this, with underbar live test, is a good free way to get going. And if you want to update beyond that, you just simply buy a license and we can make that go away and we can increase the session limit and so on. So I hope that this has been helpful. Oh, and keep in mind, this isn't just for Alpha Anywhere. This will work with any type of web server. If you want to do this with IIS, go for it. Or really anything else that you want to run under that. So I hope that this has been helpful. Thanks for watching. Bye-bye.